B1. No, not that nasty much. 4y squared plus 3y minus 1 equals x squared minus x plus 3xy. Find the points A and B, and what you'll notice about A and B is that x is 1. So we just set x equal to 1, and we get 4y squared plus 3y minus 1 equals 1 minus 1 plus 3y. 4y squared, the 3y's will cancel, so there's none there. Minus 1 equals 0. So I'll end up getting y equals plus or minus a half here. So my first point is point A, which x is 1 and a is minus a half. And my second point B also has x is 1 and the b is positive a half. Come on guys, you're late. Okay, what is dy dx at these 2 points? So now we find the derivative. So using implicit derivatives, I'd get 8y dy dx plus 3 dy dx minus 0 equals 2x minus 1 plus 3, and then I need the product rule for the xy piece at the end. That would be 1y, so just y, plus x dy dx. So this is implicit derivatives with the product rule. 8y dy dx plus 3 dy dx equals 2x minus 1 plus 3y plus 3x dy dx. So 8y dy dx plus 3 dy dx minus 3x dy dx equals 2x minus 1 plus 3y. So 8y plus 3 minus 3x dy dx equals 2x minus 1 plus 3y. I can divide by this and I have my answer. So now I need to put in my two answers. So my first one is dy dx at the point A, which is 1 and minus a half. So if I put in x is 1, I'd get 2 minus 1, and y is minus a half. Minus 4 plus 3 minus 3. So what's that? That would be 1 minus 3 over 2, that's minus a half over minus 4. An 8. And then I calculate it now at point B, which is the same thing except y is positive a half. 2 minus 1 plus 3 over 2 over 4 plus 3 minus 3. So that's 1 plus 3 over 2, 5 over 2 over 4, which is 5 over 8. So these are the two answers here. Yeah. 3 over 2, that is when I put y as a half. So 3 times a half is 3 over 2. What? Find dy dx at the point A and the point B. So in the first part of the question I had to find A and B, and in the second part of the question I had to find the derivative at those 2 points. Okay, B part now. you have fx equals e minus x cos 2x. First question, what's the derivative? No problem, use the product rule, minus e minus x cos 2x minus 2e minus x sine 2x. And I'm also using the chain rule as well to differentiate cos 2x. Derivative of cos 2x is minus 2 sine 2x. The chain rule, remember, the derivative of the outside multiplies the derivative of the inside function. Anyway, that does part 1. Part 1 is done. Part 2 is the second derivative, which is the derivative of this. So I need product and chain, e minus x cos 2x plus 2e minus x sine 2x plus 2e minus x sine 2x minus, and then sine is a plus, so minus 4e minus x cos 2x. So let me see, can I simplify this a little bit? How many cos 2x's do I have? I can just put the middle two together. E minus x cos 2x plus 4e minus x sine 2x minus 4e minus x cos 2x. Now I know if I did this right or wrong, because in part 3 I ask you to show that the second derivative plus twice the first derivative plus 5 times the original, show that that should equal 0. So if I sub all my answers in, it should add together to make 0.
What does this mean? Does it go like 0?
What do you mean by what does it mean?
No, like
What do you mean by mean?
No, like when you get this plus this equals 0.
Yeah?
Do you mean it?
No.
What
No.
is something you did do? Do you check as an answer?
Yeah, what you're doing here is, it's exactly like that question in my worksheet. Check that fx is a solution to this equation. So that's another way I could have rewritten that. I could have said, check that e minus x cos 2x is a solution to the second derivative plus twice the first derivative plus 5 times y equals 0. You're right, it's the same type of question as that, just different words. No, it's exactly the same as that, just different words. Anyway, I need to have my derivative up here so I can see it. So, just to save space, cos 2x is always cos 2x. There's no cos x. So I'll just write C for cos 2x. And sine 2x is always sine 2x, so I'll just write S for sine 2x. Yep? E minus x cos 2x here. This one. That was the derivative of this. Isn't it? I'm using the product rule for this. First differentiate this, then differentiate this, then this and this. I should have 4 pieces here. The product rule twice, yeah? Here? I'll put them together. Oh, you can, but I don't want to put too many things together because I'm going to need to expand this to cancel, so I might just be making more work if I do this. I don't know, we'll see. Second derivative, that is e minus x cos 2x plus 2e minus x sine 2x plus 2e minus x sine 2x. Oh, sorry, you're right, I could have put these together as I will do that. Yeah, I could have put this together as, no, I see what you're saying now, as a minus 3, and then just remove that. Thank you, that would save some work, which I'm always in favour of. Okay, so now let's check this. Second derivative, minus 3e minus x cos 2x plus 2e minus x. What am I doing? Why don't I add these together? Oh no, there's my answer there. Well, no, it's fine, I'll just write in here on this line as well. Minus 3, and then scratch that out. Okay. From the top. Minus 3e minus x cos 2x plus 4e minus x sin 2x. That's it. Plus twice this answer. Minus 2e minus x cos 2x minus 4e minus x sin 2x. And then what's at the end? Plus 5 times the original. Plus 5 times e minus x cos 2x. So let's see what we get here if we simplified. You notice that there's an e minus x in everything, so I can divide e minus x from everything. So I'm left with minus 3 cos 2x plus 4 sin 2x minus 2 cos 2x minus 4 sin 2x plus 5. Cos 2x, thank you. So let me see, this would be 4 sin 2x minus 4 sin 2x plus 5 cos 2x minus 3 cos 2x minus 2 cos 2x. So that would be 0 sines plus 0 cosines. So I'm left with 0. Everything is cancelled. I divided everything by e minus x, yeah. No. It just saves me writing e on the next 3 lines. And this is good, because it means if I was doing this in the exam, I would know I got part 1 and 2 correct. Or at least the mistake I made another mistake which fixed it. It happens, but unlikely. I know. What a troll, huh?
He gave you 8 in section 8.
Yeah. Sorry, Carl, this is an exam I wrote.
Oh.
That's why we're saying this, yes. So you missed all the nice questions in section 8. Yeah?